Hello, this video is for my pre-calculus students. This time we're going to be going over lesson 44. I gave the lesson in the previous video. This video we're going to go through the assigned questions. I originally had assigned numbers 2 through 14. I've amended that to numbers 3 through 13 if you hadn't caught that. And we're just going to go over them, each of them together, like we sometimes do in class. I think we've been getting a lot of information lately, and it's going to be good if we just can go over a bunch of these together. We're going to start with number 3. It says sketch the graph of y equals x minus 1 times x plus 1 quantity squared. Make sure I read that right. This is what we just learned in this lesson, lesson 44. How do you graph that? Well, as you look at it, the very first term is going to be x cubed, positive x cubed. So you know your graph is going to look like this, basically, okay? These will tell you the zeros where it's going to cross the x-axis. It's going to cross at positive 1, and I have a 0 at negative 1 also. Those are my zeros. Now, I misspoke when I said we know that's where it crosses. We know that's where it crosses or touches the x-axis. I know that because it's x minus 1 and it's to an odd power, that means it's going to cross the x-axis at positive 1. Because it's x plus 1 quantity squared, I know it's simply going to touch here at x equals negative 1. It's going to touch it there. And if I were to multiply this out, my final term would be negative 1 times positive 1 times positive 1. My final term is going to be minus 1. So it's going to cross the x-axis right there. I said it's going to touch here. So I know I'm coming down from here down from negative infinity. It's going to touch, turn back around, go through negative 1, and cross right there. That's all there is to that. Not anymore. It touches, it crosses right there. Okay? That's it for that one. Now, going on to number 4, it says use your knowledge of polynomial sketching to make a rough sketch of the possible shapes of y equals 3x cubed plus ax squared plus bx plus c. So all this stuff plus c. Again, they just want a rough sketch because it's y equals x cubed. You know, it's going to look like that. All right? Sometimes they'll show you this with just a little inflection. That's just simply y equals whatever x cubed and maybe a plus c out here on the end. They're not going to have any x squared values, any x values like this one did. This one had plus ax squared plus bx plus c. That ax squared plus bx plus c gave it this waviness, okay? So that's just y equals x cubed with no other powered variables in there, all right? Number 5 says, which of the following graphs could be the graph of y equals negative x times the quantity x minus 2 quantity squared? And I've lost all my rags for wiping the board. I'm going to erase this too. Okay? And they give you the possibilities. I didn't put up number 5. Y minus, excuse me, I wrote that wrong. Y equals x minus 2 quantity squared. Okay? So if we were to multiply this out, our very first term would be negative x cubed. So here is positive x cubed. Negative x cubed looks like this. Okay? This is x minus 0. So I know, this is x to the first power, I know that at 0, I'm going to cross the x-axis. Because this is x minus 2 squared, I know that at positive 2, it's going to touch the x-axis. Somebody say, Mr. Harrison, may say, Mr. Harrison, well, what about your y-intercept? Well, if you multiplied it out, the very last term is going to be negative 4x. There is no constant. It's plus 0. And we saw that right here when we had this just negative x equals 0. It's going to cross the y-axis at 0. So it's going to look like this one. So it has to cross right there and touch there and go down. That is what? The third option. That is letter C. So there you have it. And I've got my solution manual right here, and I'm just checking everything, and yes, it is C. Number 6, getting into integration here, something we had in the last lesson. It says find the integration of cosine u du. First of all, I want you to not worry about this du. I didn't talk about it much in the lesson. This is just saying what had cosine as its derivative, and then this du, which meant it was an integration. Just a little bit about that. We know that we start with sine. The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of negative sine is negative cosine. The derivative of negative sine is, we're back to sine again. So they're asking what had cosine as its derivative. Well, it was simply sine. So the answer to this is sine of u. Now, I want to show you why they have this du there. If they say y equals sine of u, find dy over du is what it would be, not x. This means find the derivative. Well, the derivative of sine u is cosine u. If they had just said find dy, well, how do you get dy by itself? You multiply by du, and you get cosine u du. This is the derivative. This is the differential. Just a difference in name there, and the fact that this one has the du out there. So if they say integrate this or integrate this, they're pretty much asking the same thing. Okay? So all that to say, don't be confused by that du out there. There's only one thing we've missed. We have to have this plus constant out there, because this could have been the sine of u plus 7. And when you take the derivative of 7, it's 0. So it could have been any number out there. So we put that plus c. So the answer to this question, after all that talking, is just sine of u plus c. All right? Number 7. By the way, I don't know how far we're going to get in all this. I'm going to try to do all of them. Find a function which satisfies dy over dx equals ex. One of the things I said at the very beginning of teaching this book is figuring out what the question is. They're going, what? You're going, what? Well, this is saying, what? Here's a derivative e to the x. What had e to the x as its derivative? That's what the question is. In other words, integrate e to the x. They could have written the question as that. These two are saying the same thing. Find the original function. They could have said, if f of x equals e to the x, what is f of x? All three of these are saying the same thing. Well, what had e to the x as its derivative? E to the x plus c. had e to the x as its derivative. Y plus c, because it could have been e to the x minus 44. And when you take the derivative of any constant, it comes up as 0. All right. Moving on to number 8. It says use the product rule necessary in problems 8 and 9. It says if y equals sine x cosine x, find the derivative. The other day, in maybe lesson 42, 41, I don't remember, we learned the product rule. It said if you ever had two functions multiplied by each other, like that, and they ask you to take the derivative, we have this mnemonic that says it's the derivative of the first one times, meaning it's the first one times the derivative of the second one, plus the second one times the derivative of the first one. 1d2 plus 2d1. So the derivative, or dy dx, is what I should say, I use y prime, is the first one, sine of x, times the derivative of the second one. What's the derivative of cosine? I had those up a minute ago. You should probably have those on your cheat sheet. The derivative of cosine is negative sine, plus the second one, cosine, times the derivative of the first. What's the derivative of sine? The derivative of sine is cosine. So here I multiply this out and I get negative sine squared x plus cosine squared x. In other words, I get cosine squared x minus sine squared x. And I believe they may go ahead and take that a step further. What number is this? Number 8. They may take that to be negative 1. They don't. They say that that's cosine 2x. I'd have to look on my cheat sheet. I don't have my cheat sheet right here. Probably in your cheat sheet it says you have cosine squared x minus sine squared x. You get cosine 2x. Huh? I'll take their word for it. All right. But I did get this right. I'm just checking. Okay. Okay. Because I know that sine squared x minus cosine squared x is always 1. All right. We'll move on. Number 9 says if f of t equals 3 cosine t et, approximate f prime of 6 to 2 decimal places. Oh my goodness, what are they asking there? We're at 13 minutes. I hope you're still with me. What they want you to do is take the derivative of this. Now this constant will not affect anything, at least in taking the derivative. It's going to be 3 times the derivative of these two. We're going to use the product rule. It says we're going to take the first one, cosine t, times the derivative of the second one. The derivative of e to the t is e to the t. Plus 1d2 plus 2d1, e to the t times the derivative of the second one. What's the derivative of cosine? Negative sine t. Okay? So this will give me 3 times et times cosine t minus sine t. Okay? What I did is I factored out an e to the t right here. So they want us to put in the number 6. 3e to the 6 times cosine of 6 minus sine of 6. Make sure when you do this cosine of 6 minus sine of 6, your calculator is in radians. So I'm going to do 3 and e to the 6th power. I'm going to take the second natural logarithm of 6. And it gives me 403. That seems like a really large number. I'll just take it. The book doesn't say what it is. 403.43. It says go out to 2 decimal places. Then I'm going to do cosine 6 minus sine 6. I'm going to work it out. I'm going to go 6. Oh, I'm not in radians. Mode 5. So here we go. 6, and I'm going to go take the cosine. It gives me 0.96 minus, clear, I'm still in radians, that's good, minus 6, take the sine of that. It's negative 2.8, so it's going to be plus 2.8 because it's minus a negative. Let's go ahead and work this all out. So 9.6, or excuse me, 0.96 plus 0.28 equals 1.24 times 3 times 403.43 equals, and I get 1500.76, and I believe that is the answer the book had. They had 1500.25. How we're off by 0.5, I don't know, but we're real close. May have been how we rounded. They said to round to 2 decimal places. They may have waited till the end to do that. I don't know. I may have pushed a button incorrectly, but there's the gist of how it works. All right, moving on to number 10. We're already at 16 minutes. I'm going to skip 10 for now, just because it is involved, but I will tell you that cosine and secant are two inverse functions. So when you graph it, you're going to get your cosine function like this, and your secant function is going to go like this. It's just going to be shifted to the right. Pi over 4 radians. What's pi over 4? When it's going to be shifted 45 degrees to the right. In 11, it says, find the differential dy if y equals 2e to the x minus ln u plus 4 sine t. Notice it doesn't say find dy over dx or dy over du or dy over dt. It just says find dy. And that's nice because you can't just find dy over dx because this isn't in terms of x, nor is that. This is where the differential comes in handy. It means we're just going to take the derivative of each of these separately and then add either a dx, a du, or a dt onto it, depending on what the variable is. So this will be 2. What's the derivative of e to the x? It's e to the x, and we add a dx to that. Minus, what's the derivative of the natural logarithm of u? It's 1 over u, and then we have a du out here. By the way, these are ones you should have memorized. And then plus 4, what's the derivative of sine? It's cosine t, and then we have a dt out to the side. There it is. The book will not write this as du over u. They'll just write it as 1 over u du. And as I look at my solution manual, they prove me wrong. They do write it as du over u, but that's good enough right there. Number 12. It says, well, actually, we'll come back to this one because it's a little bit more complicated. 13. If f of x equals 2 sine x, find f of x, find f prime of x, f double prime, f triple prime of x. Basically, find the first, second, and third derivatives. Well, the first derivative will be 2. What's the derivative of sine? Cosine. F double prime of x will be 2. What's the derivative of cosine? It's negative sine, so we get negative 2 sine x. Third derivative, still that negative 2. What's the derivative of sine, cosine? Or I could have thought of it as 2, and what's the derivative of negative sine, negative cosine? Either way, you get negative 2 cosine x. We have only one left to do, number 12. It's relatively involved. Number 12 says write the equation of the line that can be drawn tangent to the graph of y equals sine x when x is equal to 16.3. Okay, they want the equation of a line. What are two things you need in order to find the equation of a line? A point and a slope. A point is made up of an x and a y value. So we have to go find our y. I'm going to plug it in here. Y is going to be the sine of 16.3. Don't forget, use radians. Let's go ahead and solve for that right now. Using my calculator, again, make sure I'm in radians. Mine has switched to degrees automatically. So I've got to check it every time. So I'm going to go 16.3, then take the sine of it, and I get that y equals negative 0.558. Okay? I've got my point. I don't have my slope. My slope is just simply the derivative of sine. What's the derivative of sine? It's cosine. So my slope will be the cosine of x, or the cosine of 16.3. So it's clear. I'm still in radians. That's good. 16.3, take the cosine of that, and I get that my slope is negative 0.83. I'm only going out to 2 decimal places. It's 0.829. Check my work. Yep, we're looking good. All right. So it's y minus the y they give me equals slope. X minus the x they give me. Y minus, what is y? It's plus 0.558. Y minus negative 0.558 equals my slope. Negative 0.83. X minus the x they give me, 16.3. So y plus 0.558 equals negative 0.83x plus, what is 16.3 times 0.83? 16.3 times 0.83 equals 13.53. And I'm going to subtract 0.558. I'm going to take this one out to 3 decimal places, 29, and I'm going to subtract 0.558 from it. Y equals negative 0.83x plus, what's 13.529 minus 0.558 equals 12.971. Check the book. Woohoo! We're done. This video has already gone almost 25 minutes. I hope it is helpful, and we got that right. Found our x, our y, our slope, all in radians. You're good. Hope that was helpful, guys. Hope to see you guys soon.